All right, today we're tackling a huge question in the world of artificial intelligence. Can we get to true human-like intelligence just by mashing together a bunch of specialized AIs? Or is that whole approach a dead end? So let's kick things off with a little thought experiment. Imagine you take three expert AI systems. One's a chess grandmaster, another is a brilliant medical diagnostician, and the third can translate any language, just flawlessly. You combine them. What do you actually have? Is it some new form of superintelligence? Or is it just a really fancy toolkit?
And this really gets to the core of the whole debate. You see, real intelligence isn't just about how well you perform on a test you've studied for. It's all about adaptability, how you handle something you've never seen before. Performance is static. Adaptability? Now that's what makes intelligence truly powerful.
This big limitation of specialized AI is captured perfectly by a concept people call the 101st problem. And it's all about what happens when intelligence meets the unexpected.
Think about it this way. You can build a system that has mastered 100 different things. It is an absolute champion in its domain. But the second it comes face to face with that 101st problem, a challenge it was never, ever trained for, it just stops. It has no way to figure out something new on its own.
And this really lays out the two different philosophies here, right? A collection of narrow AIs is just that, a list of skills. AGI, on the other hand, isn't about the list at all. The whole point is to build a foundational capacity to learn, so it can tackle any task, whether it's on a list or not.
So if we just try to stitch all these expert systems together, creating this sort of Franken AI, why does that approach ultimately fail? Well, it turns out there are four critical flaws that show us why it's pretty much a dead end.
First up, we've got the problem of the gaps. See, real-world challenges are messy. They almost never fit neatly into one single box. They live in those gray areas between our areas of expertise.
So, for example, if you ask our combined system to do something that crosses over its skills, something creative like translate a medical manual to find new strategies for a chess game, the whole thing will just break. The translation bot knows medicine and language. The chess bot knows strategy, but there's nothing there to bridge the gap and connect those ideas.
And this is exactly why we need something called transfer learning. It's what we humans do all the time, right? We take a concept like strategy from a game and we apply it to our career or our relationships. A collection of narrow AIs just can't do that. Their knowledge is locked away in these little isolated silos.
Okay, the second big flaw, this one's a real paradox. If you have thousands of these little specialist bots, you run into a brand new problem. Who or what is deciding which bot gets which job? Who's the traffic cop here?
Just imagine a user says something like this to their AI assistant. A simple manager bot that just looks for keywords hears sinking ship, and it might send that request off to a maritime expert. It completely misses the metaphor, and it has no idea what the user actually wants.
So to solve that, the manager bot itself needs its own form of general intelligence, what we all call common sense. It has to understand metaphors and intent and context just to do its job. So you end up in this weird loop where you need AI just to manage all your narrow AIs.
All right, flaw number 3 is all about learning. And it turns out narrow AIs are actually pretty fragile. They can be surprisingly forgetful when they try to learn something new.
This is a real phenomenon in machine learning. It's wild. You could spend ages training a robot to be the world's best laundry folder. But then, when you try to teach it a new, complex skill, like cooking, the new training can literally overwrite and destroy its original skill. It just forgets how to do its first job. Now, AGI's answer to this is something called meta-learning, which basically means learning how to learn. Think about it. You don't forget how to walk when you learn to ride a bike, right? That's because you've internalized core principles like balance. AGI wants to do the same thing, making learning something that builds on itself instead of something that's destructive.
And that brings us to the final flaw. And honestly, this might be the most important one for our future. It's how these systems deal with the unknown unknowns, problems we have literally never seen before.
Just think about this for a second. Back in 2019, you could have built the world's greatest flu pandemic bot using 100 years of data. But when COVID-19 hit, the rules were different. The transmission was different. The old patterns didn't apply, and a system that only relied on past data would have been useless, or maybe even dangerous.
So what this really shows is a fundamental difference in how they see the world.
Narrow AI is retrospective. It's always looking in the rearview mirror, trying to predict the future based on the past. A true AGI has to be prospective. It needs to be able to look forward and reason from the ground up, especially when there's no history to guide it.
So, okay, if the Franken AI approach is a bust, what's the alternative? What does a true AGI actually bring to the table that's so different? See, AGI isn't just one more skill to add to the list. It's the entire operating system. It provides all those crucial things the Franken AI was missing. The ability to transfer knowledge between domains, to understand context with common sense, to actually learn how to learn, to reason about brand new problems, and, maybe most importantly, to learn on its own without a human having to code every single new skill.
Maybe the best way to wrap our heads around all this is with a really simple, but I think powerful analogy. The knife versus the hand.
What is it we're actually trying to build here? Are we trying to build a better Swiss Army knife? A device with more and more specialized tools. It's useful for sure, but it's fundamentally limited. Or are we trying to build a human hand, a general-purpose tool that can not only pick up and use that Swiss Army knife, but can also use a hammer or a pencil, or, and this is the key, invent a brand new tool when it's faced with a problem nobody has ever solved before?
When you lay it all out like this, the contrast is it's night and day, right? One path needs constant human babysitting to add new skills that are totally isolated and need huge amounts of data. The other path leads to a system that can learn on its own, where everything it learns informs everything else it knows. The difference isn't just a small step up, it's a completely different kind of capability.
Ultimately, this whole quest for AGI isn't just about making our current AI better at the jobs we already give it. It's about building something with the adaptability, the creativity to solve the problems we can't even imagine yet. And that, of course, leaves us with the biggest question of all. We know what we need to build, but now, how do we actually get there?